Let's solve a linear programming problem. This is a maximization problem. This problem is about olive farming. There are two types of olive farmers grow in this problem. One is pruned olive. Another one is natural olive. We have to solve how many barrels of pruned olive and how many barrels of natural olive should be grown to maximize the revenue. So this is a revenue maximization problem. So to start the problem, let's start with assuming let number of pruned, just make it short, number of pruned x and number of regular y. Okay, so as this is a linear programming problem, the first thing we have to do in here is to formulate this problem as a linear programming. So to formulate it, let's formulate it. So the first thing is objective function. So what is our objective in here? Our objective in here is to maximize the revenue, and we'll get it from here. $10 for pruned and $30 for regular olive per unit. Here the unit is barrel. So our objective should be 20x plus 30y, and we have to write maximize because we are maximizing. Okay, so we got our objective function. Now we have a couple of constraints in here. We'll write the constraints. Let's write constraints. There are two resources given here. One is labor hours and another one is aqua blend, and these are our constraints because these two things are limited. Given one is there are 250 hours of labor available and 150 acres of land available. So for pruning process we need 5 hours of labor and 1 acre of land for 1 barrel of olive, pruned olive. So 5 hours of labor, 5x plus, and 2 hours of labor here, 2 hours of labor for regular, so that should be 2y, and the maximum is 250. That means it should be less than equal to 150. So we can number it 1. This is our equation 1. All this not. So okay, then we have land. We need 1 acre of land for prune process, so we can write only x, and we need 2 acres of land for a regular process, so we'll write 2y, and the land is limited to 150 acres, so 150, that should be number 2. Okay, we have one more constraint in here. That's it. You can see here, no more than 40 barrels of pruned olive should be produced. That means x should not be more than 40. Okay, this is our equation number 3. We also have to mention the non-negativity constraints, which are I'm writing on the next page, which are x and y should be greater than or equal to 0. It can't be less than 0. Okay, so now we have our objective function, we have our constraints. Now we will solve it. Here we will follow graphical method. So we have to draw it. To draw it, we need to get, because it's a linear programming, so actually these are straight lines. So we have to draw straight lines. For each equation we'll have one line. At least 2 coordination required for one equation. So let's find them. Let's write equation. Let me make it bigger, easier. Say equation 1. What is equation 1? 5x plus 2y is we will make it equation in here. It cannot be inequalities anymore. 250, and let's make the box. I have to make it again and again, so let's copy this one for all the three equations. Okay, copy, and I will do it, say paste here, and I'll paste one more. Okay, sorry. Copy, and then paste one more time, paste. Okay, right. Right, sorry. Let's just move this one in here first. Okay, right. Okay, so the easier way to find the coordination is to find to make one of them. There are two variables, x and y, so to make each of them 0. So first make x 0. Say we assume that x is 0. When x is 0, let me show you the calculation. That will be easier for you. 5 times 0 plus 2y equal to 150. Y equal 250 divided by 2, which is 125. So when x is 0, y is 125. Similarly, we will assume y is 0. So if y is 0, x would be 250 divided by 5, which is 50. Okay, let me clean this one. And this is for equation 2. For equation 2, what is equation 2? Equation 2 is x plus 2y equal 150. X plus 2y equal 150. Okay. Now, the same way we'll make, say, if x is 0, y should be 150 divided by 2, which is 75. And if y is 0, x would be 150. Now I need to calculate in here. And for equation number 3, actually, let me show it one more time. Equation number 3 is x equal 40. So whatever the value of x, whatever the value of y, x is always 40. Say, okay, let me write one more box in here. I think it will be easier to draw rather than saying. So say if x is y is 0, x is 40. If y is 100, still x is 40. So whatever the value of y is, x is always 40. Okay. Now we have coordination for each of the equations. Now we can draw it. Let's draw it. So to draw it, let me draw it the straight line first. This is our y-axis and this is our x-axis. So I will write x and I'll write y in here. Let's draw the first one. What are the two coordination? 0, 125 and 50, 0. So first we need to scale them. I need to remind you one thing. Always maintain the scale when you are drawing. If you do not maintain the scale, it would be the graph can give you a misleading result, so be careful about that. So I don't have scale in here, but I'm just assuming this is 50 and then this is 100 and that way it would be 150. 50, 100 and 150. I will measure in the same way for y-axis. 50, 100 and 150. 50, 100 and 150. Okay, now the first coordination 0, 25, that means x is 0, y is 125, so 125 in here, the first one. Then we have 50, 0, so 50 is 0. When x is 50, y is 0. Let's draw the line. Okay, so this is our equation 1, and you have to check the equation, the constraint. The constraint said 5x plus 2y is less than 250. So when it says less than 250, that means anything left of this line is your feasible zone for this equation or inequalities. So now draw equation 2, which is 0, 75 and 150, 0. 0, 75, that means when x is 0, y is 75. It should be in the middle here. Let's change the color, it will be easier to understand. And 150, 0. When x is 150, y is 0. So let's connect them. Okay. Now in the same way, this one says x plus 2y less than equal 150, means anything below this line is your feasible zone. Now you have to be a bit careful, because below this line are these lines too, but these lines are on the right side of equation 1, so these are not our feasible zone. In the same way, let me make it big. Oops, sorry. In the same way, you see here, these black lines above these blue lines are also not feasible zone, because they are above this line, simply above this line. So it should be below the blue line and on the left side of black line. That's it. Okay, now let's draw a third one. Third one is when x is 40, when y is 0, x is 40. Say I added 40. Let's change color again one more time to differentiate them. 40. And when y is 100, it's still 40. So I will make it okay. Okay, so this is our line. Now again, the same way it said x should be less than equal 40, means anything left of this orange line is our feasible zone. So anything right side of this, we will not consider it. So now you can see here, all three colors lines are here. So this is our, I'm writing it here, this is our feasible zone. Okay, how many points do we have in here? We have, we can take this one, but you don't need to worry about this because it's 0, 0. We can't maximize anything, but I'm writing it. Say A, B, C, D, E. There are five points. So we have to take the corner points from the feasible zone to find our optimum solution. So the first one is A. We know the coordination of A. A is 0, 0. B. Do we know the coordination of B? Yes, we know. That is 75. Sorry, that is 0, 75. C. No, we don't know yet. D. No, we don't know yet. Let me take it up. E, yes, we know, that is 40, 0. Okay, now we need to solve for C and D. Let's solve C and D. Okay, let's solve point C. How do we solve C? To solve C, we need to see what lines intersect at that point. So you see equation 1 and equation 2, these two lines intersect in C. That means if we solve equation 1 and equation 2, you will get our point C. What is equation 1? 5x plus 2y. 5x plus 2y equal to 150, and x plus 2y 150. X plus 2y equal 150. Okay, we don't have to do anything in this point. We'll just minus, and we can cut the y. We'll have 4x equal 100 equals to 100. So x equals to 100 divided by 4, which is 25. So we get the value, we got the value of x. Now setting the value of x in any equation, say equation 2. So that is 25 plus 2y equal 150. It's 150, and 2y equal 150 minus 25, which will be 125, and y equals to 125 divided by 2, which is 62.5%. So we got our C. What is our C? The C is 25 and 62.5. 62.5. In the same way, we have to solve D, but solving D is easier actually. Solving D, because D is intersection between equation 1 and equation 3. Equation 3 is just the value of x equal 40. X equal 40. So we will just set the value in equation 1. So let's set the value of x in equation 1, which is 5 times 40 plus 2y equal to 100 plus 250. I don't have space in here. All right, so we get, let me make it a little big. 2y equals to 250 minus 200, which is equals to 50, and y equals to 50 divided by 2, which is 25. Once again, you got y equals 25. So x is 40, y is 25. Let's write it here. X is 40, y is 25. Now we need to see which of this point gives us maximum revenue. So to know that one, we have to make another table, and before making the table, we will write our objective function, that is 20x plus 30y. We are maximizing this. So just make a table in here. Okay, point x, y. So the point x, y, revenue. Point first one is A, 0, 0, revenue will be 0. I'll show you a calculation for the next one. For B is 0.75. 0.75. How do we calculate it? 20 times 0 plus 30 times 75. Okay, that will be that will be 2,250. Then point C. C is 25 62.5, 25 62.5. In that same way you can calculate, say 20 times 25 plus 30 times 62.5, and you can calculate it. It will give us 2375. Then you get our point D. What is our point D? It's 4025. 4025. So I did it before, so you can see 4025 would be 1550. I need one more. Say next point is E. Okay, so E is 40 and 0. 40 and 0, that will give us 800. Okay, so you got the revenue of all one, and you see what this is a maximization problem, so we need to see which one's giving us the highest revenue. And if you consider this column, you will see that point C is giving us highest revenue. So this is our optimal solution. That means the farmer should grow 25 of X, means 25 of pruned, and 62.5 barrels of Y, means regular olive. That's all.